Okay, section number 2.2, model and applications. So basically, when you are working with models, um, sometimes students find this more difficult than it is, because the requirement for you to do well on applications, model and applications, is to make sure that you understand what the problem is about. It's always going to be a story that involves numbers. So you're going to make sure that you understand what they mean, what this problem is about, and then call on your variables. And the variables you need are the questions they ask you. You name them something to be able to put them into a mathematical expression. So let's read this problem to see what they are talking about. They say um, that Gabriel invested 36,700 in two separate accounts, investment accounts. One of the accounts earned 1% annually, while the other account earned 4%. If the combined interest earned from both accounts over 1 year was $937, how much, that's where you find your variables, how much money was invested in each account? So I'm going to call my variables X and Y, where X is I'm going to let X be the amount of money invested in the account earning 1% interest annually. And then I will call the second one something similar, but I call it another name. I will call it another name, Y, for example. Let Y be the amount of money invested in the account earning this time 4% interest annually. So now I have my two variables. I can go back to my problem to see how I can set up equations that include these things. Well, we know that's the total money invested. Well, that total money invested is separated into the investment in the 1% account, and the investment of in the account earning 4%. So that's X and Y, two parts. So basically I have one equation. I'm gonna call it equation number 1. That is X plus Y equals the total amount, 36,700. That's a total money invested, and it creates an equation because they invested X. Gabriel invested X into the 1% account, 1% earning interest account, and then he invested Y dollars into the 4% earning interest earning account, which total will give me the total money invested because he only invested the 36,000 36,700 into in the two account. But also there's another situation that we can also take into account for equation 2 that gives me the total interest that he earned for the two accounts in 1 year. So that's going to be the 0.01 x plus 0.04, because 1% of 1% is 0.01 divided by 100. It's 1%. And then 4% is dividing by 4. It's 4 divided by 100, which is 0.04. Y equals the amount earned in interest at the end of the 1 year period. So that's 9,937. Well, the fact that I don't want to work with those decimals, I'm going to multiply since it's a two-digit decimal, or two-digit decimals. I'm going to multiply the second equation by 100, so I can have only whole numbers for the second equation. So multiplying by the second equation by 100, I'm going to keep the first equation the same, creating the system x plus y equals 36,700. And then the second one, when we multiply by 100, that will be x plus 4y equals 93,700. Now we're gonna solve this. I want to solve this by elimination. So if I multiply let me solve by you could solve by let me solve by elimination. By elimination, I would multiply the top one by -1, so I want to eliminate x. So multiply 1 by -1. That takes me to another system that is -x minus y equals -36,700, right? And then this one, x plus 4y equals 93,700. So x is gone if you add, and then we left with 3y equals, we're gonna subtract 36,700 from 93,000. So 93,700 minus 36,700. So that is 57,000. And then if we divide by 3, we get y equals 19,000. So that means on the account that earns 4%, he invested an amount of 19,000. Amount of 19,000. Now we need to find how much was invested on the account that earns 1%. Well, we know the first equation here that has x and y, we can just find x from that. X equals 36,700 minus y. So from equation 1, X equals 36,700 minus Y, which is 36,700 minus 19,000. So we get X equals 36,700 minus 19,000, which is 17,700. So 17,700. So that's X. So here we have the X value. The X value here, that is $17,700. So we have the amounts for both of them, and invested in the accounts that in the account 1% was X, so that's 17,700, and then 19,000. 19,000. Next problem here, we have a situation where we have, after a 50% reduction, you purchase a new television on sale for $224. What was the original price of this television? So you purchased after reduction, but we don't know what the amount was before reduction. So, and they asked us actually what was the amount, and they do want me to round to the nearest cent. All right, so anything that they ask you to find in a word problem that you don't know, you call it a name, because that's what you're gonna need. We call X be the original price of the TV but of the original price of the TV. That means the price prior to reduction. So basically we have that, then we can tell that X, 50% of X was taken off. And when that happened, the price became 224. So that tells me 0.05x. So basically it's X minus 0.05x. When you subtract X 0.05, half of X from X, because 50% is half. When you subtract half of X from X, you should get 224. Well, some of you may say, well, obviously the price was, and then you do something mental and then give it to me. No. We're solving, that's why we call this chapter, this section, model and application. This is not a mental calculus section. It's a section where you need to set up your equation, then solve it. So if you think that you can just manipulate with your calculator and get the answer, you don't show work. And that's why I'm telling you in your previous video where I was introducing you to the class, I told you that it's an algebra class. I need to see what you do on paper. That's why even if you are online, this class is still a class that should be taught correctly. So don't tell me you manipulate with your calculator to get the answer. And I know you can't get the right answer, but your work is half point on a test scenario. So that is going to be 0.5x equals 224. Then if you divide by 0.5, if you divide by 0.5, you get x equals $448, which is the price. That's the original price of that TV before reduction. Next, a similar problem as the one that we just did, but more complicated. That's why if you did not pay attention, you just do manipulations to do the prior problem, then this one would be more complicated because you can do those manipulations in more complicated problems. Look, let's read this to see, including a 9% sale tax. A hotel charges 185.84 per night. Find the hotel's nightly rate before tax was included. Round the answer to the nearest cent. So it's easy to find your x variable or your variable, your x or the variable of the problem. It comes from the question they ask you. What question they ask me here? Find the hotel's nightly rate before tax was included. Well, my variable would be x. Let x be the hotel's nightly rate before tax was included. Now, what did they just say? They say 9% of x, the rate before is tax. So that means x, price of the hotel before tax, plus what is 9%? 9% is 9 divided by 100 times x. So 9% of x is 9 divided by 100 times x. That's 0.09 x plus, that is the price now, 185.84. Now we have 1.09 x equals 185.84. If we divide by 1.09, we get x equals 185.84 divided by 1.09. That gives me 170.0, I mean 170.495. So the third round to the nearest cent, that would be 50. So $170.50. 170.50. Okay. Next problem here. In this problem, what do they want me to find? Well, in this problem, another question I could ask is, what does the tax represent? What's the actual value? Because they just said the value, the tax is 9% of the initial price. But since now we have the price, how do we get the actual tax? Tax would be what? The tax here will be, remember, tax was 0.09 times the actual price of the TV, initial price that was 170.5. So tax will be 170.5 times 0.09. So that's 15.34945. 15.345. Okay. Dollars. Well, that's a side question. That's why I put it in different color, because it wasn't asked of us. It's just me extend the actual problem. Next example here. We have another situation here. In this situation, Madeline puts X dollars, into an investment with an interest of 3% per year, and Y dollars into another investment with an interest of 11% per year. She invests a total of $4,100, and her interest earnings after 1 year is $339. Well, obviously, this problem is quite similar to the one we did in previously. From this information, we can create two equations. Obviously. One for the total investment, which is the X amount invested in the 3% account, and the Y invested in the 11% account equals the total invested, 4,100. And then the other equation will be for the one for the total investment and one for the interest earned. State both equations. Well, that's X, the equation that describes the total investment, X plus Y equals 4,100. The equation that describes the interest will be 3%, which is 0.03x plus 0.11, 11 divided by 100, y equals 339. What is the total invested in each account? Well, we're going to use the two equations to solve them. X plus y equals 4,100, and then 0.03x plus 0.11y equals 339. Now for this one, since I solved the first one using elimination, I'm going to use substitution for this one. So I'm from the first one, from the top equation, we have X equals 4,100 minus Y, and then we can substitute X equals 4,100 minus Y into bottom equation. Okay, and then what do we get now? That's going to be 0.03 times 4,100 minus Y plus 0.11 Y equals 339. 339. Now we can multiply 0.03 and 4,100. That's 123 plus minus 0.03y plus 0.11y equal 339. And then now let's combine like terms and subtract the 123 from 339. So subtract 123 on both sides. And then we got 0.11 minus 0.03. That's 0.08y equals 339 minus 123. That's 216. Divide by 0.08. Divide by 0.08. Then we get y equals 27,000. 27,000. So we got y equals 27,000. And then we knew that x plus y was 4,010, 4,100. So we can say that x equals 4,100 minus the value of y, which is 27,000. When x equals 4,100 minus 27,000 gives me x equals 14,000. So x was what? Amount invested. X was amount invested into the account of 3% interest. So 3% interest is 14,000, and then 27,000. Example 5, in this case, it's more of now we have multiple variables, but it's not word problem like word problem. But still, you have a question where you have multiple variables to solve. Always they're gonna tell you which variable to solve for. So here they tell me they want me to solve for they want me to solve for m. Well, I'm happy that m is not inside of the equation, so that makes me feel better. It's not inside of the parentheses, I meant. That makes me feel better. So I'm going to multiply by something that makes my m on the outside of the equation. So let me multiply by both sides. Let me write this. S equals h over m T1 minus T2. So if I multiply both sides of my equation by m over s, that will cancel that s over here, but m over s will cancel that m on this side. So cancel this. I'm left with the s over here, and cancel this. M is automatically outside. So m equals h over s factor T1 minus T2. Because when they say solve for a variable, they tell me to put this variable on the outside by itself, and I saw that multiplying by m over s will give me that. If you want to do it in more steps, that's fine. But basically, those are the steps that you pretty much have to. This is the step that you pretty much have to do because you multiply by that fraction. But if you want, you could say, let me multiply by m first and then multiply by s after, then you can get it. But this is the quickest way to get the answer. Here's another problem similar to 5, but this one may require more steps. Let's see. Say, consider this, and they want you to solve for W. So I'm going to solve for W. I want to keep W here by itself or anywhere, any side of the problem by itself. So I'm going to try to subtract. So P equals 2L plus the same type of L plus 2W. I want to keep this by itself, so then let me subtract this, 2L on both sides. That cancels this, so I have P minus 2L equals 2W. By dividing both sides by 2, L is automatically by itself. So that's P minus 2L over 2 equals W. Or if you divide each term of this fraction by themselves, so that's P over 2 minus L equals W. It doesn't matter which answer you give. I believe both of them would make the deal here, so it should not be an issue with it. It doesn't matter which one. Well, that concludes the note for section number 2.